It's all right. When I was your age, I don't think I slept. Thanks, Julianne. It's a little bit later for him. All right. Any questions from Emily or Amit?
No, Paul, I was just here to see if anyone else has questions. Actually, I haven't, I'm lagging behind in yesterday's homework. So yeah, this weekend's going to be a lot of work. Yeah. So
that's what we all convince ourselves. We'll catch up on the weekend.
Exactly. Yeah. The school is starting this week. So there's a lot. I mean, I wasn't able to work after yesterday's long session. I mean, the 4-hour session.
Yeah, I know how it goes.
Yeah.
That's one reason why the in-person classes usually are better. Not that we are very good at tailoring the amount of homework to the time available, but we found that people would get together in groups after the class. They'd go have dinner, sit together with their laptops, connect to the server or whatever method we had at that time, and just work until they got some solution. That was pretty effective.
Right.
We probably should have had groups this time too, or at least given a mechanism for you to self-select. Our problem was we couldn't figure out exactly how to group people in an effective way.
Yeah.
I had two comments. One's a little bit more of a question, but okay, it is a question. So maybe I'll say the comment first. At some point, maybe I'll just post it in the Slack. I did want to encourage people that are frustrated to stick with it, because after the first time I took this class, like, I don't know, 6-7 years ago, I was super frustrated. I could barely make my single pair interferograms, and I've kind of been plugging away at it. It's not always been a consistent effort, but I'm super excited this time because I feel like I kind of broke through that barrier last time, and now I really can dig in, and I feel like I'm getting it and I'm understanding it, and so I'm very excited this time, and so maybe I'll just post it in the Slack to some encouragement to people that are frustrated, because I get it. And I was not ever really been an InSAR processor, kind of always been a GPS person and a modeler. And so I'm very excited now to be able to sort of do this on my own and not have to beg people to process interferograms for me. And then the second question is unfortunately, I had a conflict at lunchtime yesterday, and so I had to miss David's second thing. And I know there's a video, and I'll go back and watch it, but something I've never quite understood, and I've heard different people explain it to me, but when you're forming time series, I know Aria made the decision to do single neighbors, or maybe n-2 neighbors. But I guess a lot of what I work on is in Long Valley, and it's a super slow deforming area. And I guess I understand the theory that if you're matching up phase pieces, you can get that slow deformation without the longer temporal baselines. But in practice, is that really with the amount of noise and variation in topography, I feel like there's so many things going on that I guess I don't believe it. That the short temporal baselines will catch the slow deformation. I wonder if, is there something intuitive that would help me understand that, or am I misunderstanding the explanation?
Who wants to take that? You guys did all the ARIA work, right? So there are more than just pairs, nearest neighbor pairs. I believe that there's a number of 6-month.
Yeah, in some, depending on the study area, there's N-2, N-3, N-2 plus annual interferograms or semi-annual interferograms. It definitely depends on the study area.
Okay.
And in terms of general time series approach, there is no, like, especially in SBUS, there is no right answer for, or like one answer, how many interferograms you should make, or like how should be your network construction. It usually depends on the data, your signal, and all those things are usually comes with after a while of trying and failing and seeing how things work. But Yunjun's paper actually stated that 5 connections are the optimum number of connections to be able to resolve a network. For example, N-5 is the highest number you need to be able to optimally resolve a time series signal.
Okay.
And in my paper, I had studied during my PhD, it was like, what is the slowest signal we can detect? Or what is the, if we want to reach a 1 millimeter per year velocity uncertainty, how long should our time series be? And usually the answer to that with a complete network is 5 years or more.
Okay. Yeah.
So these are considerations that you can keep, but in the end, there is no one right answer. I don't know if Cindy, or would you like to have something?
So just keep plugging away and try and see.
Yeah, no, it sounds right to me. There's also, with the nearest neighbor pairs now, there's a lot of evidence that if you're not careful, depending on the region, you can lead to the very small biases in the long-term signal. The Italian group who invented SBAS argues that if you're careful about your selection of pairs, that's not necessarily true. It has to do with the closure phase, and it's not fully understood yet, I'd say. I think somebody mentioned it's an active area of research, which means we don't understand what the hell's going on.
Okay. Yeah.
But so, and using longer time-based pairs tends to pull down that bias to closer to a 0 bias. So I think it does help in general to use the longer term pair because it gives you the leverage to, as you say, have lower noise for a given deformation signal.
Okay, thanks.
Yeah, where possible too, though, because in some cases, these longer term annual pairs or even 6-month pairs are completely decorrelated, or there's not much left. So again, it's very much catered to specific study area. It's not one, universal answer.
Yeah. Okay. So yeah, taking into account the deformation signal, but also you kind of getting rid of the pairs as they start to decorrelate, being too long in time. Okay.
Yeah, there's some balance there.
Well, that being said, also, I would like to share an experience that I had during my PhD. I was able to make a coherent interferogram from ERS data that was 13 or 11 years long. And yeah, it worked. The interferogram was coherent. There was 11 or 13 years time span. So you never know, but usually it's safe to assume that it is a shorter term interferograms will be more coherent.
Yeah,
that's pretty long.
and to your first point about people sticking with it, absolutely, it takes a lot of intuition. Especially if you're not an electrical engineer, it takes a lot of intuition from looking at data to know what works and what doesn't work. The tools have also improved since you took it before. These guys have really done an amazing job of.
Yeah, absolutely. I think that was part of my difficulties the first time around was I spent so much time trying to get everything installed in the right packages and everything like that, that I was, but I think it was Thursday before I even started being able to work on the homeworks. So
Yeah, no, it's
this is super easy this time. Really, really nice. So
yeah,
thank
please do post that, and given that the experience you have, if you have suggestions for improvement, I think there's a post-course survey that includes not just how well did you comprehend what you learned, but also was the course any good in general. You can make any comments to that effect for improvement. We would appreciate it greatly.
Yeah, definitely.
All right, we got a few more people. David was here. Oh, there he is. He is still here. Everything all right, David?
Yeah, I'm in the car, but I can easily unmute in case there is a question that I need to answer.
Thank you.
Okay, I have a question on ARIA 2. Is that okay?
Go for it.
Yeah, this is the first time I study how to use ARIA 2. And I think the time it was challenge for David yesterday. He had a short time, I think. So it is confusing to me for some question like this. I found it is very useful, as David mentioned yesterday, that it is a link between interferogram and time series analysis. And in the notebook, David downloaded data from somewhere. I understand that it is for tutorial, but I'm wondering, for example, in my practical application, what is geocoded unwrap data I download, or I just use ICE product for ARIA 2? Because you download the data somewhere yesterday, but I don't know if, for example, if I want to apply InSAR for an area and I have the same data like that on website to download, or I have to process interferograms myself and use ARIA 2. So it is my confusion.
So that's go ahead.
Oh yeah. So all I was going to say was that this is meant, ARIA tools is meant to handle, process ARIA products themselves, not ICE outputs. So this is standard packaged ICE products, which are taken, and if you use the ARIA TS setup, you could prepare them for time series analysis through MintPy, but MintPy could also handle ICE products directly as well. So it's not like you have to go through and prep with ARIA tools. That's meant explicitly for ARIA products right now. It's not meant to package up other sources. And like I said, you could proceed directly with TopSap outputs through MintPy and the like, and with the stack processor as well. But I don't know. I'm sorry to cut you off, David. Did you want to add something else there?
Yeah, so we will add the packaging. So really we use ICE outputs and we package it in as a NetCDF. We are in the progress of adding that to the ICE repository. So users can package up any ICE processing into that same ISAR beta product. So in the end, that format is independent or it's sensor neutral. So you could do this for ALOS, you could do this for Sentinel and any other sensor as well. That's the beauty of it. So technically speaking, you could use it for other ICE sensors, but it requires a little bit of work in case you want to add in your own specific pairs. In terms of where you fetch the product, so there is a big archive available at the NASA DAC at ASF. So you can the demo which we did was for one specific track. There's many more data as well. So you could check if that is available over your region of interest. If that is not the case, you could also let me, Sim, or Emre, even Paul, know what region of interest you would like to see added, and we could try to add it in over the next few months as well. And similarly, if you have any specific pairing requests, we are currently expanding the archive, so we can welcome requests, and we can add in new study areas in case it's not yet covered. If you have more information on how to access the data, you can have a look at the area download notebook. That gives a little bit of a background, and I think that also links to a video from a year or 2 years ago, which gives a lot more introduction on the archive, how the data has been processed and generated, and how you could use it.
Okay, thank you for that answer. And I have another question. I think it is very quick for this one. From TS setup, ARIA TSS setup, you have a couple of steps in prep A. Prep A and prep B. I feel that the two step download the same data set. Is that right? I mean, for example, if I download data from prep A, so I don't need to do again in prep B because I feel that they are the same data. Or you have it is not original code, you change, maybe you change something. So I think they are just, they download the same data. I'm not sure that is right or not.
Okay, so is prep B, I'm opening it up on my end to refresh my memory, but prep B, is this download part commented out? Or maybe you could share your screen just so then we're on the same page.
Yep. Can you see my screen?
Yeah, I can.
Yeah, I see here in this step, it is prep A.
Okay.
You download a zip file, ARIA TS setup.zip.
Yeah,
and
that's
then you use this one to unzip.
Mhm.
And after that, we have a directory named products and unzip, or in, I think it's in the programs here. This is the first time I see the name like this, but I guess it is.
Those are your ARIA products, yeah.
Okay, but it is here in step B, download data. Yeah.
There are two steps. So there's two options to execute the notebook. One of them is using stage data, which we had already downloaded and just zipped up, and that is way faster to download because we download directly from the S3 bucket, which is at the same location. The step B option is if you would have set the field to false at the top, then it would not have used the pre-stage data. You would have actually needed to download it from the DAC yourself. So it is just two ways of executing the notebook. One of them using pre-stage data, and the other one is actually fetching the data yourself.
Okay, so you mean this one change to true or false here, because you already downloaded before, so you make it this one false. For my case, for the first time running, I use this one as true, and it download.
Yeah, that's it. So yeah, if you set to true, then you download the pre-stage data. It's just meant to save time here, but then you could go ahead and download the data as well by setting that to false, and then you go through the stage B. And that's why you say you see in the cell B, it says if stage data is false, then it goes and performs that function. But if it was true, then it just ignores that. So you're running it, but it's not doing anything. So
and do you understand the idea, the concept of staged data versus data that's in the archive? I think maybe that might be the confusion. Staged data means that it's in a Amazon area that has already been pre-configured with a set of data to be used for the time series. It doesn't have to go, the notebook, if you use the stage data, it doesn't have to go back to the ARIA archive and search for the data and assemble it and then download it from the larger DAC repository. So they staged it. They staged a subset of data in a place that is very quick to access. That's what that means. So
Okay.
if you say true or false, if it's true, use staged data, it's fast because the data has been staged. It's a small subset. You just access it and proceed. If you say false, then it says, okay, I'm not going to use that. I'm going to try to go back to the DAC and do the entire process as if I'm not taking this class, but I'm just doing my research. That's what that means.
Okay, yeah, I understand that in case, as you mentioned, if we don't download the data, and I can use ARIA tool with my own data, right? As you mentioned.
If you say use staged data false, then yes, you could set your own area and go back to the archive and get any area you want. That where an ARIA product exists.
Yeah, it is. I know that.
Okay.
But it is my confusion is that as in prep A and prep B, because in prep A download data and prep B also download data.
But that's the point. That's what I'm trying to explain.
Okay.
See, both of those say if use stage data or if not use stage data. So only one of those will execute.
Yep.
And that depends on what you want, whether you want to use the stage data, which is a subset of data that the instructors created for the purpose of quickly getting to the rest of it. Or if you want to do your own research, you don't use the stage data. So you say use stage data is false. Get it?
Yes. Yep.
Only one or the other of these steps will be executed, depending on what you want.
Okay. Yep. Thank you.
Yeah. Okay, let's see what's happening over here in the chat. A whole other stream.
There was another request about a process about going about requesting an AOI for standard products from Amit. So yeah, right now, I'm not sure of the logistics, but we're going to be taking requests in the near future. David, you mentioned something about that right now? About
yeah, so perhaps we could make a simple Google sheet or something like that. That I don't know, Paul, could be shared with the full survey or could be shared during the course. We have one day left, where we would just ask for perhaps a bounding box, long latitude, perhaps a track number from Sentinel, and based on that, we could internally figure out the region of interest and make an AOI. And if we can collect the email address and the affiliation, then we can reach out based on those requests.
Yeah, that shouldn't be a problem. We have the Slack channel, which will stay open too. So
yeah, so Sim perhaps even make a Slack channel area regions of interest or something like that, and could be shared with the users, and we can ask for those 4 specific things: bounding box, affiliation, name, and track numbers, and perhaps the period of interest. If they know the pairing, then that would be great, and then we can take it from there.
yeah. Yeah, I could set that up.
okay. Any other questions?
Are you guys answering questions about the installation and stuff like that?
Well, no.
Not yet?
Well, yeah, it's Friday, right? The ASF is supposed to have created a instruction set. ASF is not on right now. I'm assuming that by 1:59 p.m. this afternoon, 1 minute before the end of the course, that will be available. But I'm not exactly sure whether I don't know if they're running into any difficulty or they just are too busy doing other things. So please keep asking, because it's important to me actually that the students have the ability to do that. So at 10 o'clock, if you can join then, I think Franz will be, let me just check availability. I have a list of when people will be on. You can also post it on Slack again.
Oh, I just did, but I figure if you're here, maybe we can have a conversation, which is easier than the technical stuff. But yeah, I mean, it's fine. I can wait.
Franz says he'll be on at 10 o'clock today. So.
All right.
Yeah.
Hey, Paul, this might be like a little bit off the topic question, but I was wondering, I mean, when I'll be processing most of this stuff, I'll just be using one single image. I mean, like 250 kilometers by around 250 kilometers, one single scene. So what type of resources am I looking at? Like if I have to request my advisor or someone, okay, this is the machine that I need to get this work done. What type, I mean, what kind of thing I'm looking at?
When you log into this this course, when you log into InSAR Lab, it tells you what the resources are for this particular instance.
Okay.
Not when you log in, when you start up the server, I guess is more to the point. I'm not sure which it is, but in any case, it'll give you a list of what this machine's capability is. I'd say that's kind of, it's not the minimum capability, but it's close to the minimum in my view.
Okay.
If you could have a GPU enabled machine, that would be even better.
Okay.
So what do we get with this? Let me see. Let me try here. I sign in, I log in, and it says it's an M5A 4X large EC2 instance, which has 7 CPU, 31 gigabytes of RAM, and 500 gigabytes of storage. So you see that server option when you start up on InSAR Lab.
Okay.
So I think that's kind of, you could probably get by with less RAM. Storage with these images, you always need more storage. So 500 gigabytes is probably the minimum.
Okay.
And the more cores you have, the better.
Okay.
At home, I have a machine that's made by a company called Lambda. It has 50 cores. It has 2 high-end GPUs in it, and I think it costs $18,000. So that would be, I'd say, the minimum. That would be a nice machine for doing your work. It also has a 16 terabyte hard disk on the inside.
So to give you an explanation on the drive needs, so if you do a region of interest like Sentinel, let's say 1 frame, these days for 6 or 12-day repeats, you get close to about more than 100 acquisitions. Each of them are 4.5 gigabytes in size. So just the raw data, if you would do a stack processing job, just staging the raw data would be half a terabyte that you would need. Generally, when you start processing and you make the stack and you take one polarization, you're left with about half of that because it's still at full resolution if you would extract only the SLCs. So ISCE does a lot of virtual processing and can keep these files virtually aligned. But yeah, these days the volume which you need for the disk is pretty large just for a single area. unless you do some clever processing and cleanup along the way.
Yeah, so get a lot of disk. Disks are cheap, so it's not a big deal.
Right. Okay, that gives me a sense of what I should be looking at, but yeah.
But you're in Texas, right?
Yes.
So there's a Texas TACC, Texas supercomputer
Right, yeah.
that you should have access to. Probably you can get it for free. JPL actually has some sort of an agreement with Texas, and we can use those supercomputers for free as well.
Right. Yes. Those first, I want to get everything running on my local machine. Then I'll go with them and okay, I have it running. Figure it out how I port this to your computer. That would be the best way. That's what I was thinking.
Fair enough. That is the right way to do it. It's much more efficient.
Yeah, and most of them do not have access to. I mean, if I have to download things like that, their compute code do not. I don't think so. They get access to the internet. So for some reason, though I'm at Texas A&M, we do have access to TAC, but we have another HPC right here, and yeah, that's but yeah, that will be the second step from my is to get this running on my personal machine. And
okay. Yeah.
You see later.
So tell them you need 40K.
Yeah, that'll be something.
It's not that much money. I'm sure he or she can find it.
All right. Yeah. Yeah. Thank you for the good overview of this thing. It's easier for me to move on from here.
Good. Yeah. Good. Any other questions? They've got a new person. Excellent. One, two, three, four, five. Now we have about an equal number of instructors and students. Any questions from Michael or Emma? New joiner, new additions?
An extremely teeny tiny thing that the ARIA products page linked in the notebook is to an old URL.
Aha.
That's a good one. Yeah, we should remove that and only link to the DAC URL.
And which notebook is that again? Did you see that in?
The one I clicked on was from ARIA Plot.
ARIA Plot, okay.
Under the download options.
Okay, we'll update that.
So you'll do that, Simran?
Yeah, I could go ahead and I could tweak that and push that. Just swap out the links.
Great.
This is really great though. Following on my earlier comments, I really like the Jupyter notebook formats too. It's really, I haven't used them that much, but it is a really, really nice way to work through lecture material and then have the lecture material integrated with the functional material.
I fully agree with you, which is why we've embraced it so much. I have to say the first year, maybe I said this earlier this week, but the first year that we taught this class, I didn't really have the opportunity to listen to everybody's talks later in the week for whatever reason. But I wanted to do my own processing using ARIA tools and other techniques as well and do some comparisons. So rather than bothering David directly, I did bother him at some point, but rather than bothering him directly, I just listened to the videos and went through the tutorial notebooks myself, and I could get everything I needed from that with a couple of little questions. So it was really very, very effective for me. And, you know, even though I know the InSAR stuff, I don't know much about the details of the ARIA processing and MintPy and all that other stuff. So I consider myself a novice user in that area as well. Very, very effective. DKRZ provides free cloud computing resources for earth science research.
I'm actually just trying to browse the ASF DAC for what are the search options to get ARIA products? Is it in the?
You would change the under sensor. I don't know what it's exactly called, but it's on the top left. I think it currently shows Sentinel-1. You would click down and you would go to ISAR beta product. I think it's called the Sentinel-1 beta, and you would change to that product type, and then you would be able to see the standard products on the facet page.
Yeah. So just
it says S1 InSAR and ISAR format.
yeah. So from here you go down
there we go.
right there. Yeah.
Okay,
Yeah.
nice.
Make sure
Okay.
to do that. And then from there, you see what I did. I went to the. Sorry, it's really glitching out on my end, but you select your study area here. If it cooperates, try again. And okay, so it's fine now. I go under filters. I probably went to, sorry, a bit quick there, but I hit filters here after selecting S1 InSAR. After selecting my study area, drawing the polygon, I go to filters. I go to file type under additional filters, and I hit standard product.
Okay.
Yes.
Nice.
And then from there, you could decide if you want to have a specific time range. That's up to you, what particular path, so on and so forth. But, yeah.
Okay. Okay, nice. That's cool. Thanks.
Yeah.
On a completely other, well, maybe I'll wait for Franz. I'm curious about the, we're trying to make some cloud decisions for our observatory data management. So, I can wait till Franz gets on, or somebody from up there.
So one thing, I don't know, David or Simran or Emre, you can comment on. I know that ASF is offering, they're actually going to have a new version of their hype service for computing interferograms and I guess time series on demand. How deeply are we working with them on that, or is that completely independent? I know Yunjin has been working with them to integrate MinPy into that, right?
So the hype output generated through the gamma processing software, I know that they have added in a similar pre-processing or / loading step into MinPy. I don't think currently that the MinPy processing software is included as an on-demand capability to select through their API. I know that Giant is, Train is. They have AutoRift as of course as well, because of the measures project with Alex Gardner, mapping glacier streams. Under our Access project, we're working very closely together with ASF to do more cloud-based processing alongside the data. As part of that, we are working in collaboration on hype-related stuff, standard product-related stuff, as well as changing virtual data processing in ISCE, etc.
Okay.
I had a question on the homework from the first session yesterday. I was wondering if we could just clarify what it was, because I wasn't sure from looking at the syllabus and then the GeoSync folder for that lecture.
Clarify the homework.
On the syllabus, it says like final plots of baselines and time diagram and coherence matrices, but I wasn't sure. I was confused if that was in a notebook that maybe I was missing.
I think we updated it in the description. I updated at least 2 days ago, which was more like make plots of extracted coherence, unwrapped phase, incidence angle, because that is what comes out of the extract notebook.
Oh, sorry, that was the extract, the area extract file that we talked about. Okay, thanks. Sorry, I think I missed that. I thought that was like a separate thing. Okay, great. Thank you.
So there were I'm looking at the syllabus now. There's 2 segments that you gave, David. One was on the time series theory, and the second one was on the ARIA tools extract stuff. I think probably the time series theory, there was really, we did not change the description there of the evidence for homework. I'm not sure that is actually relevant. We should probably delete that.
Yeah. Sorry, I don't think there was no intention to have homework for that portion. Sorry.
Okay, thanks. I just wanted to make sure I wasn't totally missing something. But so I'll focus on the area extract instead. Thank you. Yeah.
There isn't even a notebook to, are those slides on GeoSync?
The slide, I was also going to ask, I didn't see the slides. I just saw the README, I think, in the folder.
Yeah, we need to get those slides posted.
Should be able to do that later today.
Sounds good. So we don't have assessment for that one. No homework. I'll just type in no homework. That's easy. Made the student's life easier. All right. Any other
Paul,
questions? Yes.
I will need to jump off at the moment.
Thanks for supporting, David. Good luck.
Thank you.
All right, any other questions? If not, we can break a little early. I wouldn't mind.
Hello?
There is a question from Michael, and I think he was trying to talk.
Oh, okay. Oh, here it is. I know there's a difference in LOS displacement. So is there a benefit from comparing ascending and descending? So generally, if you have two different look vectors, then you can better resolve the vector nature of the deformation on the surface. So I think, yes, there's certainly a benefit for looking at both. And since you can't interfere ascending and descending data with each other, you have to make if you're going to do time series analysis, you would do it individually on the two and then combine them in a vector sense after the fact.
Can you hear me, Paul?
Is that the right, did I answer the right question?
Hello?
Yeah, we can't hear you very well for some reason.
Sorry.
Yeah, you sound very low, your volume.
Can you hear me now?
Yeah.
Yes.
Sorry, I was having some mic issues. I'm working on my desktop.
Yeah.
How would you go about combining the two after computing a time series separately for ascending and descending?
There is already a small piece of code in MinPy that you can use ascending, descending to horizontal that combines both, converts them to a horizontal, but it's not very extensive. It's just taking the velocities and just combining them. But practically, you would need to combine them in, well, not practically, but there's a mathematical way to combine them, and you would need to follow that, and that's what MinPy is applying in that program. So there's a small piece of code that you can use.
I see. And is that the same? Are we going to be covering any aspect of that today when we're going through MinPy?
I don't know exactly what Yunjun is going to be showing today, but I think as soon as you get the basics of MinPy, it will be just running one line of code. So it will not be very complicated compared to the rest of the stuff that he needs to go through probably.
Thank you. Yeah, I had an opportunity to install MinPy a couple of weeks ago, so I've just been working through with a specific data set of my region of interest, but there's a lot of I guess nuances that I'm not fully well versed in, so I was just curious.
Yeah. MinPy is very powerful, but there are also a lot of bells and whistles that you need to be careful about to be able to have 100% control on your process. Yeah.
Thank you. All right, that was it. Thank you.
Nice. All right, anything else? The last office hours for this week. Although the 10 o'clock hour is kind of like office hours. All right, well, it's 7:52. I think we're close enough to the hour. We've exhausted the questions, so I suggest that we call it a day or call it an hour, and we'll see you all back at 10 o'clock. Sounds great. Thank you, everybody. And thanks to the instructors, Emre, Simran, David, Leanne, for participating. Appreciate it. Bye-bye.